Okay, so the simple rules of differentiation. So this will be a reasonably short one, but this is mainly because it's not too difficult despite how it may look. So as you can see in the top left here on our screen, we've got all the rules for simple differentiation, and they look a little confusing, but we're just going to deconstruct them a little bit. Let's just start off with the first one. So we've just got to, maybe I'll just draw, say f of x equals 2x squared plus 3. So obviously the first rule states that a constant will become a 0 when you find its derivative. So a constant in this scenario is the 3. So what they're saying is any value without an x in it, or whatever the symbol may be. So let's just say we've got f of x equals 3, therefore f dash x will equal 0. Now the second part of this, and I might just get rid of that 2 for a second there, is we can see x squared, and this represents this second scenario here where we've got x to the power of something. So what we'll do is we'll just split this up along here, and so we've got f of x equals x squared, and what it tells us is that, and I might just draw the square a little better, is that the power, which in this scenario is 2, will be placed in front of the x, and then we'll minus 1 from the power. So in this scenario, f dash x will equal 2x to the power of 1, which just equals 2x. Now if we just look at the second part, the second half of it, we've got this and this. And so then this is where we can bring back, we can bring back our 2x squared, for example. And so we can see that this will actually be split into 2 parts when we actually find the derivative. And so where f of x equals that, f dash x will equal the coefficient, so that, times by the derivative of 2x, which is what we have there, times by 2x, which will equal 4x, like that. And so a better way to think of this is that you've got 2x squared, and all you're doing is, you can completely forget about the 2 at the front, you're just doing this method here, and all you're doing is then after you've done that, you're just timesing it by the coefficient at the front. And then the last one here, all we've got to do is we've got, say, x squared plus maybe x to the power of 3, and using just a simple method, we know that f of x, considering both this rule and this rule, will equal 2x, because we've just calculated that one here, and since we know the coefficient goes out the front, then that will equal 2x plus 3x to the power of 2, because we've done that minus 1 and put 3 in the front to give us what we need. And now something else worth stating is you'll be asked questions in different forms. So you might, this form obviously we're looking at f of x and you're trying to find f dash x, but you could also be given y, and they say you need to find dy over dx, and both of these forms represent the complete same thing, so that is equal to that, but it's just a different way of presenting it based on maintaining the history behind how all of this was derived and created, and the 2 different people involved in actually defining this method and this method, but both are ones you will encounter. Alright, so practicing a few examples, I should mention that sometimes this could look scary or confusing, but it's worth mentioning that it's actually a lot more simple than it looks, and once you start to get the hang of it, you realize how easy it truly is. So let's start to jump into it. So question 1, we've got f of x equals 3x, and so what we can think of it is that right here we've actually got x to the power of 1, and so looking at it in a complex way is we've obviously got to times this 1, we've got to times the 1 here with that, and you've got to do 1 minus 1, blah 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 blah. But an easy way of thinking of it is, because it's x to the power of 1, we can just get rid of the x, and then that just therefore f dash x equals 3. As simple as that. Basically, each time you're just cutting one x down and timesing its power by the coefficient at the front. So we can do that for this next scenario here. We've obviously got x to the power of 5, so f dash x will just equal the coefficient times the front, so 5 x to the power of 4. So it's just taking away 1x and moving that 5 to the front. Easy. And now next one, we've got a little bit more complicated. So right here we've got a few different variables, and so it may seem a little confusing about what to do, but it's actually more simple than you realize. We can literally just combine and simplify this, and so we can just have x to the power of 3 minus 4 x to the power of 2, and so then we can go, okay, cool, now that we've got this, we just use the method we'd used before to find f dash x. So that will just be, move the coefficient to the front, 3x to the power of 2 because we minus 1 power, minus, so now we've got 2 times 4, so 8x, and it's to the power of 1, so we can just leave it at that. And then for the next one, we've got a similar thing here, but it's a longer equation. So then, and what you can see now as well, is we've got y instead of f of x. So here we've got to say, therefore, dy over dx equals, and then we can go from here. So 3 times by 2 is 6x minus 1 power to the power of 2, then minus 12, because 6 times 2, x to the power of 1, so we just leave it, plus 7, because it was only singular x to the power of 1, so we can just take away the x. And then because we've got a coefficient here at the end, we know that all coefficients without an x just become 0. So we could say plus 0 or minus 0 and then go evaluate from there, but we'll just leave it at that. It's as simple as that. Alright, so now we've got a few more examples, but this time we've got fractions. And this will involve a slightly different approach, but it's still pretty easy. So having a look at the first one, we've obviously got y equals 1 over x to the power of 4. And so before we actually find the derivative, we're just going to say that this equals x to the power of negative 4. And this is because if we were to move this upwards like that, the power would become a negative. So like if you had x to the negative 1, that is equal to 1 over x, which you should hopefully know already. So we'll just get rid of that. And then what we can do here is we can go, okay, now that we've got that, therefore dy over dx equals negative 4 x to the power of, now we've got a minus 1 again, so x to the power of negative 5, which we can then say this, which equals negative 4 over x to the power of 5, like that. And now we can do a similar approach for the next one. So we can say this equals x to the power of negative 1 minus 4, oh, better 4 than that, 4x to the power of negative 2. So therefore, dy over dx equals negative 1 x to the power of negative 2. And then we can say plus, because this minus will make, the two minuses there will make a positive. So then that's plus 8, because 4 times 2, x to the power of negative 3. And we know this will equal negative 1 over x squared plus 8 over x to the power of 3, like that. And then the final one here is a little bit trickier, but I reckon we've got it in the bag. So we can just bring this one up, and we know, because this, if we brought this one up here, it'd be x to the negative 2, but we've got to apply it to this one and that one individually. So then you can look at the powers, and it will be, well, just to evaluate it simply for us, it'd be 3 minus 2, and then minus x, obviously it'd be 1 minus 2. So we just evaluate that completely, and that will just give us x to the, just x to the 1, so we can leave it fine, and minus x to the negative 1. So therefore f dash x, because this one here is fx and these ones were y, and so then that will give us f dash x equals 1, because we just know x goes to the 1 when we find the derivative, minus plus actually x to the power of negative 2. So then that will equal 1 plus 1 over x squared, like that. Alright, so let's have a look at a few more examples that include roots this time. So what we're going to do is, obviously with the first one, we've got 6x squared root x. And so what we're going to need to do before we actually find the derivative, like similar to what we did with the last one, is we're going to have to evaluate it. And so we've got 6 at the front still. And what we're going to do is we've got to multiply these two x values. And so just at the bottom here, x to the power of 2 times by root x. And hopefully what you should already know is that root x does equal x to the power of 1 over 2. And what you should hopefully already know is when you multiply values, such as the 2 we've got here, the exponents or the powers will add. And so what we can do is that will be, so 2 plus 1 over 2, which we can also represent as 2, so then actually 4 over 2, sorry, plus 1 over 2. And so that's sorry for my scribble, but what we'll do is we know that because of that, this will just be x 5 over 2. And so we can actually import this into this equation at the start here. We can just say 6x to the power of 5 over 2. Then we can find the derivative, just like we have done before. So f of x equals, so we'll have the exponent here times by 6x, and then 5 over 2 minus 1 is just 3 over 2, and this will equal, so 5 over 2, in other words 2.5 times by 6 equals 15, x to the power of 3 over 2, and this can also be shown as 15 x root x, just splitting up that term like how we combined it near the beginning. So if I just draw a dividing line in this one here, this one's a little bit difficult because we have a few other values, but I reckon we can do it pretty easy. We know that this is equivalent to 15, and I'm going to bring up these values to the top. So 15, and actually if we have a look at it, this, if I just do it down here, get rid of that arrow for a second, 3x like that is equal to x 1 over 3, sorry, because that 3 is there now rather than a normal root which represents a 2. So then we can put that into it and say that equals 15x to the power of, well, it's now negative 1 over 3 because we've brought it up. And so we can find the derivative. So therefore dy over dx equals negative 1 over 3 times by 15 and x to the negative 4 over 3 because we've minus 1, which equals just negative 5x negative 4 over 3, which we can also show as equaling negative 5 over x to the power of 4 over 3, like that. It's a little bit of a scribble, but you get the idea. Alright, so let's have a look at one more example with a slightly more complicated scenario, but I reckon we're up for the challenge. So we've obviously got this here as the function, and so before we actually find the derivative of this, we're going to evaluate it. So this will equal, it's equivalent to negative, and I'm going to go x in brackets, negative 1 over 2, because we've got the root there, which is 1 over 2, we've brought it up, the coefficient's 1 anyway, and we've got negative at the front, and so then that's that plus, we can leave x to the power of 3 the same, because we don't have to worry about that. So therefore, dy over dx is equivalent to, so 1 over 2, negative 1 over 2 times by negative 1 at the front, so that's 1 over 2, x to the power of negative 3 over 2, plus, and this one's pretty simple, 3x to the power of 2, which equals, oh, give us a bit more room there, which equals, and I'm going to move this x at the bottom, so it'd be 1 over 2, and that would be x to the power of 3 over 2, but we're going to do what we did earlier, and just say x root x, because it's a lot smoother, plus 3x squared. So now having a look at the question, it asks us find the value of dy over dx when x equals 1. So we found the value of dy over dx, but we just got to find when x equals 1. And so we can say when x equals 1, and if we were using f of x, we would say f dash and we'd say 1, but unfortunately we don't have that, and so that's why we are using, we'll just use red, that's why we're using when x equals 1 here, just to show what we're doing really clearly. We say dy over dx equals, and we're just going to put in the function, which is 1 over 2x, so 1 root 1 plus 3, 1 to the power of 2, and because obviously x equals 1, this makes a lot of these really simple. So it's just 1 over 2, because root 1 equals 1, and times that by 1 equals 1, times that by 2 equals 2, so really simple. Plus 1 to the power of 2 is 1, so plus 3, and we can, I guess we can just say that that equals 7 over 2, and it did ask us to interpret its meaning, and what this means in this scenario is on the graph, because we found the derivative, when x equals 1, the y value is just, we can just say the y value is 7 over 2. Simple.